Hi, everyone, and thank you for joining us. Today, we're going to talk about one of the biggest challenges in healthcare, how we can improve research outcomes, and more specifically, the models we're building. We all know that models are as good as the data that they've been trained on, but the data needed to drive better treatments, better models, better patient outcomes already exist. So what's the challenge? The challenge is that the data is fragmented across institutions, protected by regulation, and oftentimes too sensitive to move or share. As a result, many high-value research initiatives slow down, not because of lack of expertise or intent, but because of the friction around data collaboration. So my name is Adi Eierstein. I'm running the product management at Duality. And in this session today, we'll explore how organizations are moving beyond that friction, enabling secure collaboration while maintaining privacy, governance, and control. It's my pleasure to welcome Rodney Gabriel. Rodney, thank you very much for coming over. I'll let you
Yeah.
introduce yourself, and let's start with some background, your research area, and the challenges that you are seeing around data collaboration.
Yeah. So my name, as you mentioned, is Rodney Gabriel. I am a associate professor of anesthesiology as well as biomedical informatics at the University of California, San Diego. I hold a position as a vice chair of perioperative informatics. And with that position, I run a research lab that is specialized in leveraging a lot of artificial intelligence modalities to answer a lot of questions in healthcare. And so a lot of the clinical focus has been around one is around predicting opioid addiction and persistent opioid use after surgery. It's an important topic because of the current opioid crisis in the United States. And as perioperative providers, when patients get surgery, they're exposed to opioids. And so we need a really good way of identifying those who are higher risk of becoming dependent or may abuse opioids so that we can take a different approach to those specific patients. And that's the point of these predictive models, is to apply what we call precision medicine. And then I also do some AI research around the intensive care unit, using a lot of the data there to predict outcomes and complications in certain patients. And as you can imagine, there is a lot of data involved with a lot of these studies. And so it's really important to think about, how do we model this data? What kind of data do we have? How diverse it is? And that's where the challenges are. I find that the not the most difficult part is not actually developing models and programming fancy AI predictive models. The hard part is actually the data. And as you mentioned, models are only as good as the data that's put into it, right? And so if you don't have good data, if you don't have granular enough data, if your data is not diverse enough, it doesn't represent the population enough, then the model's not going to be very good. And there's a lot of ethical concerns with that. And those are some of the points that needs to be addressed amongst anyone really that is working on developing deployable, feasible tools in the healthcare setting. So I'm excited to talk about it.
Great. Those are really important research areas, obviously. So we touched upon the challenge around the data, but other than the data, when it comes to collaboration between different institutions, where do you see those projects get stuck? Is it only on the data, or more on the legal side, or sometimes
Yeah.
organizational challenges?
Yeah. Because we're dealing with sensitive patient information, there's a lot of securities rightfully around sharing data, right? Even getting data within your own healthcare institution can be challenging, right? You need to make sure you check off all the boxes so that you can access data. And those things include ethical review by your institutional review board. It requires that you do this in a secure environment so that you minimize the risk of data being released, and that's not good because patient data is private. If you take it a step further, because you want to start working with other institutions because you want to diversify your data, you want to expand your data, then it becomes really more challenging because you're asking to obtain data from a healthcare institution that is not where you work. And you can imagine, if you bring data from another institution and then put it into your own environment, that raises a lot of eyebrows from the other institutions. And so there has to be a lot of steps involved with security, again, with ethics. And that process can take some time and that it can slow down research and development of these models. And a lot of people may be turned off by this and try to find different approaches and not go the route of actually using other data that's out there. And so it can be very challenging. And then imagine you want to work with 10 other institutions, 20 other institutions. It gets really hard. And then you think, okay, there's also some data that they may not agree to share because it has a high risk of de-identification, right? And so one example is clinical notes. If you want to obtain clinical notes from another institution, that's a little bit more challenging because it's hard to de-identify that data. So there's an extra security measures with that. Then it becomes even more difficult. So there has to be other ways around this to make it more feasible to build AI models in healthcare that represent patient data from multiple institutions. And that's where a big part of research is trying to figure that out.
Yeah, absolutely. And I think that's where federated learning solution can be really applicable here because by design, federated means that you don't move the data outside of the organization. You can train the data where the data resides, and you basically don't need to do this de-identification. Can you share a bit more from your experience around project that you handled in the past with federated learning or with other privacy enhancing technologies? How you tackle those challenges?
Yeah, so we've worked on a couple of federated learning projects in the past, and one example is around the COVID-19 pandemic. So this was affecting a lot of institutions, and we needed to better understand what the patterns we're seeing in COVID-19. But it's hard to see global patterns when all you can really look at is your data at your own institution. And so there was one study that we did was where we looked at multiple University of California healthcare systems, right? And so UC system has a bunch of healthcare institutions and tested out models around predicting COVID-19 outcomes through a federated approach. This paper was published in Nature Communications, where we built a federated learning model that actually also leverages blockchain technology so that in some methods for federated learning, you have a centralized approach where you have all your institutions with their data, and then there's a central server that updates the models where each institution sends their model updates, and that central server then fixes the model, then sends them back to the institution. When you do a blockchain technology with this, is what we did, you don't have to have that central server to do it. And the reason why that's important is because what if something interferes with that central server, then the whole thing just crashes, right? And so if you have it in a blockchain sort of technology, then you don't have one area where you can basically disrupt the entire federated learning process. And so we demonstrated that, but it shows that when you're with COVID-19, we have to look at multiple healthcare institutions. We can't just look at our one. And so that's a prime example of how federated learning can really improve looking at something that's very important like that pandemic at the time.
Yeah. And how do you deal with the fact that every hospital structure their data differently? So I think in a more broader sense, one of the challenges that we're seeing is around data harmonization and the
Mhm.
ability to prepare the data between different parties in a way that you can actually run and train your models. So how do you deal with that?
This is a very interesting challenge because it is very true that different hospitals they structure their data differently, they represent their data differently. And so when you build a model and you create variables that sort of do a one-to-one matching, it's very difficult, especially when you're looking at more and more data. The way we went around this with a previous project, project we're doing now, is really think about how you can leverage language modeling, right? And so the language modeling can represent any kind of text into some kind of embedding. So it represents it into a numerical vector and any text. So now instead of doing one-to-one mapping, for example, a patient in one institution might have diabetes, but then in another institution, it represents it as diabetes mellitus. Instead of finding every common variable and mapping them to one variable, which is time consuming, you can just map it to a language embedding using language models and then represent and use those numeric those vectors to represent the data. And so when you start leveraging these like foundation models, then you can really get around improving the way you do data harmonization. It's something that done where we were predicting risk of opioid addiction. We built the model in one electronic medical record system and then validate it in the Veteran Affairs data set. And then we found that there was a lot of data in the Veteran Affairs data set that was not present in the training, the development set, the EHR that we used to do it. But when we did this language modeling approach, we were able to leverage all that very easily and harmonize the data that way. That's just one approach. That's one of the approaches that we do. And for that project, it worked very effectively.
Yeah, that's super interesting. And on a related note, what kind of research or AI use cases simply aren't possible without cross-institution collaboration in your mind?
Yeah, so this is a very interesting question. A lot of studies will develop models. I think most models actually, a lot of predictive models, especially if it's predicting something very important. And we can do one example if you're going to predict if somebody, let me give the example, is going to develop an opioid addiction. And you build this model in one institution, and then it's trained on just the data at your institution. But the population in your institution could be very different than a population in the other side of the country or in a different part of the world. So that model is useless. So it's just not possible because it's not going to predict something that's very sensitive to predict. You don't want to have a lot of false positives when you're trying to predict risk of opioid addiction because there's a stigmatism to it. So you don't want to have these false positives, and you're going to have them if you test this model in a different institution, right? Because the patient population is completely different. And so you have to get around that. You have to, yeah, and this applies to not just opioid addiction, but multiple different outcomes. I think most of them do. If you're trying to develop something that you want other healthcare systems to use, it might be completely useless if all you did was train it in your own institution.
Yeah, that's super interesting. And if I go back to your previous point about using LLMs, so did you use LLM for different data set? You use different LLMs, or you need everyone's to use the same LLM for your workload or for preparing the data?
It would probably make sense to use the same language model just so that you have consistency in how the data is represented for the end model. So for us, we use the same language model for both the validation site and the developmental site.
Okay. So what kind of advice would you give for organizations starting the cross-institution collaboration? How can they actually start with it?
Yeah, I think I don't, not a lot of people have some expertise in federated learning and the idea of it. And so I think the most important thing is you work with experts that are comfortable and have experience with doing federated learning. You work with your information technology team so that they know it's all about where you're going to store your data securely so that it can connect with whatever program you're using for federated learning. And that's always a good step. You don't have to build this from scratch, especially if you don't have technical expertise in it. And so that would be my advice is after you develop an idea, like this is what we want to do, and you also develop partnerships with other institutions. Once you have that information, the next step is, okay, let's work with somebody that can help us with the federated learning piece. And you do that. You also, in parallel, have to work on, when we touched upon this, is data harmonization. How are you going to harmonize the data? And that's going to get very challenging. It gets more and more challenging depending on how much data you want to use, what kind of data, and the clinical question. But it's no easy task. It requires a lot of collaboration and communication across all the teams. So that's the general idea of how you set up that process.
Yeah. And another question is related to what we just covered right now. If each institution insists on keeping control of their data, who actually owns the model that gets trained?
Yeah, that seems probably more of a legal issue that I wouldn't be able to tell you exactly who's going to end up owning that model. That should probably be a discussion that's had with each institution before they start working on this and then decide on some. Every university might have different rules and some might have different personal preferences. So it's definitely something to discuss before doing all of this. But I don't know. I don't think there is a strict rule saying, okay, in this situation, X owns the model. So it's not an easy question to answer and require a lot of legal consultation and in consultation with all the institutions involved.
Yeah, definitely. When it comes to collaboration, there are beyond the technical side and beyond the ability to develop the model and basically set up the data sets and everything. There are so many things that you need to do in terms of agreement between all the parties. So the legal side, we often see that one of the hardest part is basically to make all the parties confident about the solution from a security perspective. With the most sensitive data, how can we ensure that there is no data leakage, that there's no use of the data and things along those lines? And what we found out as a useful thing is the ability to create a risk analysis report where
Okay.
we can actually show the different parties how those different privacy enhancing technologies can protect different part of the collaboration or the workloads that they're running. So what I'm saying is that there is a risk analysis table that we can basically create to show the different parties how you can protect the data using, let's say, federated learning, then trusted execution environment, differential privacy, and each and every layer basically protects different things. Completely on agreement with you that there are so many things beyond the technology on the legal side that needs to be agreed upon with all the parties.
Yeah, and I can imagine when going through legal and security at each institution, it won't happen overnight. It's going to take a couple of weeks for everyone to look at all of the security measures to make sure they feel comfortable before they pull the lever. Yeah.
Yeah, yeah. Tell me about it. Yeah, it's oftentimes we need to go through this journey with
Yeah.
each and every organization, which each and every IT and security folks to basically, first of all, teach them or educate them about privacy enhancing technology, and
Yep.
then help them to understand how those technologies can actually help them to protect the data in a way that address their legal requirement.
Yeah, and I think once you set it all up at one institution, and then it'll be a lot easier to keep working with them moving forward. It's just that initial step of getting it past security and legal. But once you get past all that, then you can really become very productive after that. And so really if you can, the more institutions you get involved early on, there's so much more potential the more that you get involved and that get past security once you pass this initial step. So I think patience and persistence is definitely important when you're trying to prioritize doing federated learning across institutions.
Yeah. On that note, can you share what's your thoughts about federated learning versus a centralized approach in terms of accuracy? In an ideal world, you can put everything in a centralized place and that's it. But
Yeah.
because of all the stuff that we just discussed, regulation, security, you cannot really do that. But the question is, what's the gap between running a centralized training model or federated one?
Yeah, you pointed out centralized just seems the easiest, and it seems like the model would be optimized and trained the best because all the data is in one place, and you can train a model with all the data knowing what all the data is there, so it can identify patterns that are all there. And so you think a centralized approach would make a more accurate model, and it's also just a lot easier because you don't have to do, what federated models do. You don't have to do all those steps. Of course, that's better in theoretically, but it's just not realistic. So we have to move past that. And so then you think about, okay, federated approach now, you don't have all the data in one place. And in fact, the only thing that's being shared is the model parameters, right? The model weights, and it's going back and forth and getting averaged. And then you think, okay, will this degrade model performance, right? And we've done some experiments where the model performance isn't degraded compared to a centralized approach. But I think it's going to be very different just depending on the kind of data you're looking at and the kind of questions and how much your data you're going to look at to really ask to really know if the model degrades versus if it doesn't. So every model is different, but from what we've been seeing is in some of our studies is that the degradation of model performance does not significantly decrease when you're doing a federated approach compared to centralized.
That's super important. And the other dimension is cost. Oftentimes, we've been asked around what's the cost of centralized versus federated? And from our experience, it's even cheaper because you don't need to send everything to a centralized place, which require a very large server oftentimes. And when you do it in a federated way, it's more cost effective.
Yeah.
Just interesting to see or curious to see what's your take on that.
Yeah, I think it's both cost and time effective because then you don't have to you can skip the step where you have to share the data and then store it in a one centralized place. And then you don't have to worry about what happens if that central server gets hacked or something. You don't have to worry about all of those things. And so you skip that step and you can start doing these projects once you have your data at your own site. And so you save time and yeah, it definitely can be cost effective.
Yeah. And Rodney, I know that you prepared a couple of slides if you want to share them.
Oh, yes. So these slides, the reason that I wanted to share these, can you see my slides?
Yeah.
Okay, so the reason I want to share this, it really I want to just talk about this is not talked about enough. A lot of researchers and companies in AI, they want to just jump to developing predictive models for whatever it is and be excited about it. But I think we really have to think about the ethics of it. And the reason why I want to talk about the ethics of predictive modeling is because it really lays the foundation of why federated learning is important. Okay, and so in this slide, what you see is in the right is a bunch of main themes around AI ethics. And so we touched upon privacy and data governance. We talked about accountability, who owns the models. But I wanted to touch upon a lot of the ethical issues around AI because it really touches upon a lot of stuff that we discussed today and why it's important. Some of the things we discussed was privacy and data governance, which we have a good understanding of how important that is in the healthcare setting. But I want to focus on two things, reproducibility and fairness. And then when we look at these things and we can really understand why data diversity and essentially federated learning are really important when it's about developing AI models and that are deployable and feasible and useful. So reproducibility essentially just means you build a model in one institution or one set of data, and then if you test it on something else, a different institution, a completely different data set, is the performance of the model reproducible? Okay, that's very important because that tells you it's useful, we can use it. Fairness, we start thinking about, okay, are there certain populations, whether it's due to social reasons, the patients that are of lower income or patients with less education, race, ethnicity, are there certain populations that are not where the model is not doing as well or is more inaccurate? And that's also important. And that it tells if there's not enough, if the fairness is it's unfair to certain populations, that means that certain population is not well represented in the training data. And so something's missing. And so that tells you, okay, we need more data. We need more diverse data. We need data from another population, another institution. And this is very hard. Reproducibility and fairness is hard to maintain if you limit your model, your training model to one institutional data. And so that's why we need to expand and look at more. So to give you an example, this is can you see the next slide here?
Yeah.
So this was a model that was built on the electronic medical record system that was aimed to predict the risk of acute kidney injury in a patient population. And then they tested this model on multiple different hospitals to see if it was reproducible. What you see here is on the plot on the right is the area under the receiver operating characteristics curve. that was produced at each site. When they tested the model individually at each site, the AUC at that site. And so that's a marker of model discrimination. And then the higher it is, of course, the better the model is with sensitivity and specificity. And you can see that half the population or half the institutions are below what the model was supposed to do. So you see some institutions with an AUC of zero point 0.6 and zero point 0.7, whereas you see on the very right it works very well. So this is an example of the model not being reproducible. And it shows that the model was built in one institution, but when you try it on different ones, it's just not going to work the same. And so this is what you can see. And you see this, I'm sure if you run tests on most AI models that are published and you run it on multiple institutions, you might see something similar here that where it doesn't produce the same level of performance and accuracy compared to other institutions. This is another example where they externally validated a sepsis prediction model in hospitalized patients, and they validated it it was built in one institution, and they just tested it on their own institution, so a separate population than the training data, and showed that on the right side, you see the performance, it suffers with positive predictive value, negative predictive value when tested on a different. So it also shows that, okay, this model sounds good, but it was not reproducible. And then I touch upon fairness, or we can call it algorithmic bias, where this is something where are certain populations, marginalized populations, are the models not doing such a good job for them? And it's really important to also take this into account because when there is algorithmic bias, it can perpetuate disparities in care. So let me give you an example. You have your training data, and in your training data, your patient data, you have an underrepresentation of a specific population because maybe they're a minority at your institution where they may not be a minority at another geographic location. But in your training data, there's an underrepresentation of them. Okay. And you train your model to using this data that underrepresents a specific population. And that model learns a lot of embedded stereotypes that may be associated with that group, and it doesn't generalize well in that subgroup. And then you introduce this model into another institution to use it, and then there's going to be bias. So if physicians start using it, and you don't know about the algorithmic bias, maybe they start delaying or missing diagnosis just in that population, right? And they get suboptimal treatment, and it causes a disproportionate amount of harm. And then that impacts care. And so there's going to be continued inequities in care, and the data is going to start continuing to look bad. And then you use that data again to train more models, and it just keeps getting worse and worse. And so this demonstrates that another important part about using multiple data sets through a federated learning approach is you can theoretically reduce the amount of bias that's starting to build in these models. So federated learning can help diversify your data so that you can improve reproducibility and improve fairness. The points that I'm making here is that AI, it's only as good as what it is taught. So it's only as good as the data. And it really just comes down to the data and what that data represents. And so sharing and diversifying data in healthcare is not easy. And so that's why we think about ways to make it easier to share data, and federated learning is one very effective way to do it. And that's what I wanted to share to really point out why this is important.
Yeah, and that's super interesting. On that note, do you assign different weights to the different data sets? So let's say that different organizations have different data size, right? And not all data points are equal. So how do you balance between those different records across institutions?
Yeah, that's going to be something that you need to play around with, right? Tune those hyperparameters while you're testing your data and then testing the performance. A common way to do it is that one institution, if they're contributing 100 times more data than another institution, then the model weights that it brings to the model is weighed more, and so they have a priority. Whereas if another institution has only 1/10 of that data, then it might have a lesser weight. But that's one way to look at it, but you have to really think about, okay, are you going to always have to do that? What about certain variables? Maybe one institution represents a certain group or variable more often than the other, and then maybe they should have a higher weight. And so it's something that you have to play around with and then determine what's the best, which provides the best reproducibility and accuracy when you play around with these parameters.
Yeah, makes sense. What do you think about where do you think this market is heading? Where are we going to be in 2, 3 years from now in terms of the technology, the research? What's your thought on that?
I think it's definitely going to grow. I think what we're seeing in the AI world is you're seeing a lot of the use of large language models and a lot of healthcare applications that use large language models and they're selling their product. A lot of times their models are trained on just one set of data and then they think they can use their models and then use it in your hospital setting. That, as I mentioned, may demonstrate that it's not reproducible. It might somehow some algorithmic bias. So they need, I think, moving forward, we're going to start looking more and more. How can we optimize these large language models and at the same time overcoming the barriers of sharing all of this data? And federated learning is the way to go with it. And so I think if we want to continue, and specifically in healthcare, if we want to continue seeing more reproducible models, more fair models, then the use of federated learning should continue to grow. And that's where I see it going the next few years.
Yeah, that's super interesting. And we can't really wrap it up here without mentioning agentic AI. So one of the things that come to mind for agentic AI and federated learning is the ability to create agents that can actually create the entire workflow that includes the harmonization, and the data preparation, and then the model training. So I know it's just very early days, but I'm just curious, what's your take on that? Do you see a way where federated learning or federated architecture can actually run agents at the edge that are doing more than just training the model, but actually taking care to the
Yeah,
entire workflow? Yeah.
I'm actually very excited about that idea. Earlier, I told you that building the model is not the hard part, it's the data and the data pre-processing and data harmonization. Right now, a lot of how it's done is essentially manually through multiple meetings and saying, okay, what's your data look like? How are we going to harmonize it? It's a lot of manual work, and not all, not, some of it can be automated, but it's going to be a barrier for those with less experience or those with massive amounts of data to actually do effective federated learning. It's the data harmonization process. So if there is a way through agentic AI to make that process a lot easier, then it will reduce that barrier, which I think is a huge barrier to for multiple institutions to collaborate in a federated learning approach. I have no doubt that's possible. You're seeing AI just explode, right? And there's no reason it won't be able to learn how to data harmonize. And so with that kind of technology, it's going to be a huge, huge lift or a huge benefit to increasing the feasibility and the usage of federated learning across multiple sites.
Yeah, 100%. We're seeing pretty much the same thing that customers are asking us on how we can leverage agentic AI for doing all those data preparation, harmonization, and I can
Mhm.
definitely see a future where we are actually launching agents at the edges that take
Yeah,
care for those type of workloads.
yeah, exciting.
Yeah, very exciting times. Absolutely. So, Rodney, thank you very much. It was insightful getting all those practical advices from real world experience. This is really great. And with that, we'll wrap it up. Thanks everyone for listening. Hope to see you in the future webinars.
Thank you so much.